They started out a generation ago as simple black and white tennis games on a TV screen. Today's video games are vivid, sophisticated and fast-moving, driven by state-of-the-art computer software featuring the latest in high-tech graphics. It all started in 1952 with a Cambridge University PhD thesis on human-computer interaction. The student invented a primitive noughts and crosses game on a vacuum tube computer, the very first computer game with graphics. A team at MIT designed the first recognized computer game in 1962. Then in 1972, a Stanford student invented the arcade game Pong, which later became a home video game to play on your TV set. The whole process begins with the people who form what's called the core team. They brainstorm in meeting after meeting to hammer out the concept, how the game will look, and how it'll work. Then they plan out the production schedule, assigning who'll do what and when. The team break down the game on paper and color code the components, then post them on a bulletin board that'll act as the production's nerve center. Work on the artistic concept begins. Artists sketch out the characters and backgrounds on paper in a scene-by-scene storyboard. Graphic artists recreate those storyboard drawings three-dimensionally on a computer. This step enables the development team to use the latest in computer animation technology to bring the game elements to life by adding colors, textures, shading, and of course, movement. After developing a preliminary version of each character, the animators superimpose a skeleton. By manipulating the skeleton, they make the character move. They experiment with different movements until they decide on which ones they'll use for the game. The animators have to design every movement each character can potentially make in the game. That's 700 movements for this main character alone. Once that's done, they flesh out the character's features and costumes to completion. Other animators work on the backgrounds, the game's playing field. Once they have a rough version laid out, they refine it by adding details, colors and textures. To give it depth and dimension, they use virtual lighting to create shading and shadows. To advance the storyline, this particular video game is intercut with 1-minute animated movies. These segments, called cinematics, are animated in high resolution to produce a top quality image. The interactive game, on the other hand, is in low resolution because computers can't process high resolution images quick enough for fast moving play. So the animators have to create every character twice in both high and low resolution. Meanwhile, for the cinematics, the storyboard is animated using rough draft characters. This is simply to calculate the timing and to map out a clear path across the backgrounds, so that the characters don't collide with the scenery. To make the cinematics action look realistic, animators use a technique called motion capture. They videotape themselves performing the action, then use animation software to reproduce it on the computer. Computer programmers create the video game's menu settings, among other features. Computer engineers design the artificial intelligence, the brain that runs the game, which is made up of thousands of computer codes. For the cinematics, actors record the characters' lines. An audio technician mixes the voices with music and sound effects and synchronizes everything with the action. Now they take the video game out for a test drive. Do the characters move the way they're intended? Do they go where they're supposed to? Or do they run into trees and walk through walls? This is the development team's last chance to rid the game of any bugs. After that, the company can finally market this video game and hope it becomes a hit.